Let us solve the given differential equation. So first thing first, what we have to do is rewrite the differential equation in terms of dy over dx. So here I'm going to leave it as an exercise for you to distribute x times cosine of y over x with the two terms, and similarly y sine y over x with these two terms, and rearrange the terms to obtain dy over dx. So we should get dy over dx equals to y over x times cosine of y over x plus y over x squared times sine y over x whole divided by y over x times sine y over x minus cosine of y over x. Right. So this is a homogeneous differential equation. The reason behind this is if we consider this to be the function f of x comma y and make the substitution x with lambda x and y with lambda y, then it should give back the original function f. In that case, when this particular criterion is met, what we say that our function f of x is a homogeneous function, and since our function is homogeneous, this differential equation is going to be a homogeneous differential equation. Now the next task would be to solve this equation, and here we cannot use the method of variable separation. Only reason being, this function f is not equals to the product of two functions g, which is purely a function of x, and h, which is purely a function of y. Only when they are equal, or we can say the function f can be expressed as a product of g and h, then we can apply the method of variable separation. What we will do here, we will make a substitution y over x equals to v, and we will see that our differential equation reduces to a variable separable form. So let's do that. The y over x equals to v, that's also y equals to vx. Differentiate both sides with respect to x gives us dy over dx equals to v plus x times dv over dx. Now we will rewrite our differential equation as v plus x times dv over dx equals to, so we have y over x, so that will be v times cosine v plus v squared sine v divided by, we have y over x sine y over x, that will be v times sine v minus cosine v. Now next we will subtract v from both sides, and this should give us x times dv over dx. We'll combine these two terms on the right hand side, and that will give us 2 times v sine of v divided by v sine v minus cosine v. Now we will separate the differentials, and this will give us v times sine v minus cosine of v divided by v cosine of v equals to 2 times dx over x, and there is also a dv term here. Let me write it in front. Now we see that we have a separable form. So our original differential equation has reduced to a separable form, and now we can integrate both sides. If we use the method of substitution here and take v cos v equals to some variable, we should get the numerator, and the value will be negative log of v cosine of v. So I urge you to check out the calculation, and this will be equals to 2 times integration of dx over x, so that will be natural log of x plus the constant of integration, let's consider c. So we have negative, so this is also log of v cosine of v whole raised to the power of negative 1 equals to log of x squared plus log of c. What we have done here is apply the properties. So this is log of v times cosine of v equals to log of c times x squared. Now you can get rid of the c Get rid of the logarithm from both sides. So that will give us 1 over v times cosine v equals to cx squared. And let's substitute the value of v with y over x. So that means we have the cosine v that will go into the numerator to give us secant of v, and v is y over x. And this v, let's take it to the right hand side by cross multiplying with cx squared. So we have v times cx squared, and v is y over x. So y over x times cx squared. The x and x gets cancelled, and that leaves us with secant y over x equals to c times x y. So this is the required solution to our given differential equation.